Hi, everyone. I'm Paula Harvey of Tejon Ranch Conservancy, and today we are going to do 5 different journal entries called hidden figures. So really what we are doing now with this lesson, lesson 16, hidden figures, it's actually 5 separate lessons. And all of it is to practice all the different kinds of measuring that we went through and introduced to you in the last lesson. So there are all kinds of numbers that can be used when you are journaling. Another reminder, ABC is the writing part of what you are observing. 1, 2, 3 is the measuring part. That's what we are focused on right now. And the drawing, the picture, or the diagram, the sketch is the third thing, all of which increase your ability to observe things and to see those patterns that are so important in science. So if we are going to use, for example, a plant, we might want to look at the numbers of the petals on a flower, the height of a plant, the distance between the nodes on the stems of the plant, the number of visitations by pollinators, the number of different pollinators, the number of aphids that you might see for each leaf, and the speed of growth over a longer period of time. All of those things can be measured on one plant. So finding those numbers behind your observations requires that you think very creatively as you are observing. And the more you do, the more information you are getting about the thing that you're curious about and learning about. So what we are going to do is practice how to improve our precision in measuring through 5 different exercises on this particular lesson. So let's get started. So first of all, in this 5-part lesson, you're doing counting, measuring, timing, and estimating. 4 things. The 5th one is combining all of them into one beautiful journal entry that uses a little bit of everything. You're going to practice each of those 4 things, and you're going to do as many measurements of each of those things in each individual measuring entry. And then you're going to put that all together at the end. The goal is for you to really practice quantifying. The more you do, the better you get at measuring different kinds of things. Any event can be timed, any object can be measured, and there's always things to count everywhere. So even though there's a lot of things to do to satisfy this particular long lesson, there's so many things to count. You'll never get through it all. It's fun. What are you going to be able to do once you've done this entire lesson? You're going to count by timing, measuring, or estimating the things that are around you. You're going to find different ways to quantify your observations, and you're going to put those in your journal entries. You want to be creative. Go wild with this. There's no penalty for being wrong here. What the penalty is not trying. But if you try different things and it turns out that that doesn't work, then you've learned something, and that's what this is all about. You're going to use your journal to record all of these things. If you like the way it looks, terrific. If you don't like the way it looks, you might want to write a reflection piece at the end of that journal entry to talk about what it is you don't like. But don't pull it out, don't throw it away, don't cross it out, don't erase it. All of this is a learning experience, and journaling what you're learning is part of what having a good journal is all about. I learned so much more by my mistakes in my journal, and I can go back and look at those mistakes and analyze what I did wrong, and I can see how much better I get every time. All right, so you're going to create visualizations at the end of each one of these in the form of some kind of graphic organizer. Over here, what we have is a stem and leaf plot. Remember, we talked about this in the last lesson. The stem is the tens place. So here is 10, 20, 30, 40, 50, and 60. And the numbers here are whatever it was that is being counted, but this is connected to the first number. So if this is a 10, 10 plus 3 is 13. This is 14, this is 16. And so what's happening here is someone is counting the number of birds at a watering hole by the hour. So here's the first hour, and then they're seeing 13 birds, and they're seeing 14 birds, 16 birds, and so on. And that's how a stem and leaf plot work. You will have an opportunity to try them. They look a little confusing at first if you've never done them, but once you've done them, they're really fun to do and they look really cool. All right, again, a little more on measuring. When you're measuring lengths and distances between things. So you can use tools like rulers, measuring tapes, goniometers. Remember, a goniometer is something that looks like a protractor, but it moves so you can determine the angle of something. So you could determine what's the angle of the leaf that's coming off of a stem, for example. You can also use biometrics. And in this particular case, I want you to copy this down and then take some measurements of these things, put them in your journal. So even if you don't have measuring tools with you, you will always have measurements that can be used just by using different parts of your body, your height, the span of your arm, the length. And don't forget, even though it's not in here, but the length of maybe your pinky finger, or even the length between the joint and the tip of the finger. Those small measurements are going to be very useful as well. And compare those to a ruler. But remember, we are using the metric system, not the standard system. Okay, so here's your first practice. Here's the first journal entry that you're going to do today. And then the next journal entry you'll do on the next day, but this was the first one. I want you to pick a place, a nearby natural object, and measure as many parts of it as possible. We already talked about measuring the parts of a plant. It's a great way to start. There's plants all over, whether it's a weed in the crack in some concrete or it's in a field, there's always a plant. Go ahead and measure that. That's an easy thing to measure, and you can use tools and you can use biometrics to do all of that. So that's going to be your first activity. So now we're going to talk about the next activity, and this is completely separate from the first one. So you're going to do a completely new journal entry. This one is on timing. You're going to be timing something. You can use timing to record anything that is moving. Examples of things that are moving. We see animals that repeat behaviors all the time, and we can measure and time the intervals between those behaviors. So for example, if you're looking at a deer that's grazing, you'll notice that it'll have its head down and it'll be eating grass for a little while, and you can time how much time it's spending eating the grass, and then it'll pick its head up and it'll look around. And how much time does it do that? And how much time is the interval between eating the grass and pausing and then going back and eating it again? Those would be things that you could time. Here are some other things. If you see a hawk soaring above, you can time how long it takes, how long it soars before it flaps its wings. You can also count the number of times it flaps its wings, but we're talking about timing here. So if it's soaring, how long is it soaring without flapping its wings? Let's say a bird is singing. You might want to listen to that song and hear that it repeats itself. How long is that song? Different birds have different songs, and many birds have several different songs depending on what they're doing. So you want to measure the length of time that it takes for example, for a sparrow to sing its song. You also might want to measure the amount of time between the first time it sings and the next time it sings. If a duck dives underwater, how long does it stay down before it comes back up? That's another thing you can measure. You can also measure weather patterns. So you could listen if it's a really windy day. Wind moves in gusts, just the way waves do at the ocean. If you're at the ocean, you could measure the amount of time between the crashing of each wave. You can measure the amount of time between gusts of wind. So that's another thing that you could measure. You can use a stopwatch, or you can use the timer app on your smartphone, or if you don't have any tools, you can estimate the amount of time by saying hippopotamus. So 1 hippopotamus is 1 second, 2 hippopotamus, 3 hippopotamus. Each time you say that, it's a second. So you can count that way as well. All right, here's your assignment for counting by timing. You want to find something to time nearby and record your data in your journal. Remember ABCs, you're going to write, I notice, I wonder, this reminds me of. You're going to ask questions. When you ask those questions, remember to use the language of uncertainty and come up with some possible hypotheses. Use the words of uncertainty, possibly, perhaps, and maybe when you answer those questions. And you don't have to be right. You just have to come up with some interesting answers to your questions. And then a sketch diagram or a drawing to show the visual of your observation. Count with a timer and count by hippopotamuses. If you don't have a timer, obviously you'll count with hippopotamuses. If you do have a timer, do it both ways and see how each works for you. All right, so that's your second practice, and that's your second journal entry. Okay, now that you've done 2 journal entries, we're going to talk about distance over time. So speed is what we're going to be talking about. To measure an animal's speed, you're going to measure the distance that it moves over a particular period of time. If you're sitting in a car and the car is driving at 50 miles per hour, what you're saying is if you drive at that speed for 1 hour, you will have gone 50 miles. We're going to do this at a much slower pace. You want to find an animal that you can measure their distance in a reasonable way. The easiest one to do is a snail or a slug. So in this particular case, we are going to use a banana slug. And we are going to lay a ruler next to it because they do not move fast at all. And we're going to time how long, how much distance that animal moved in 1 minute. So if you were to find that the animal started at 0 centimeters on your ruler, and by the time 1 minute was up, it got to 10 centimeters, then what you've determined is that this slug moves at 10 centimeters per minute. And it is written this way, 10 cm/minute, but it said 10 centimeters per minute. Now, while a stopwatch is a good tool for this kind of thing, let's say you were trying to determine how long it takes for a liquid amber leaf to turn red and fall off a tree. Clearly, it's not going to be in minutes, and it's going to be over a period of days. Therefore, you're going to be using a calendar instead. So keep in mind that a timer can be a variety of different tools. Okay, so as soon as we start counting, we are going to discover patterns. And those patterns are going to help us understand our surroundings better. We can count numbers of individuals, number of organisms. We can count, for example, the number of turtles that are sunning on this rock. We can count the parts of an organism. So we could count the number of pine needles in each bundle. That would actually tell us what the species of pine tree it is. So notice there's 2 bundles. These are the bundles here. And in each bundle, there are 3 pine needles. That could tell us which pine tree this is. All right. You can also count non-living things. For example, you could be in a field and you'll see a whole bunch of gopher holes. You're counting gopher holes, but you're not counting gophers. And that's something that you can also be counting. But one of the things that I mentioned in the last lesson, I'm going to repeat it. You also want to count in context. If I'm looking at these turtles, I would like to know not only how many turtles are on this rock, but what's the temperature outside? What's the temperature of the water? Maybe I'm curious about whether they're out because it's too cold. Maybe that's one of my questions I want to answer. Maybe it's the time of day. Are they out first thing in the morning? Are they out at the heat of day? Remember, we talked about ladybugs. Let's say we found 25 ladybugs. Did we find them over a period of a whole day? Did we find them on one branch? Did we find them during, in 10 minutes? Did we find them over a large expanse of space? So you want to be very precise when you're counting and give more information and think about what kinds of questions those generate. When you're counting, remember to use hash marks or tally marks, and then to create graphs or maps and charts to display that data. So for example, in this particular case, Fiona made a map of the things that she was counting, and then she identified certain kinds of plants in that particular area, and she counted them. So she counted with hash marks, she counted with numbers. She also counted with percentages. What is the percent of the total number of things for each of these things? And then she took this and she created a circle or a pie graph. And this gives you a really easy way to see what is the most common plant that was in this particular area. And then also keep in mind that she did the same thing with this map by color coding it. So each of these colors represents different plants. Okay, so here's what your next journal entry is going to be. This is a counting journal entry. You want to find many things that you can count nearby, and you're going to record your data in your journal, ask questions, use the language of uncertainty to come up with hypotheses for your questions, and then use sketches and diagrams to show those observations even more. Count as many things as you possibly can. Use tally marks when you can. And remember that with a tally mark, it is 4 vertical lines and 1 diagonal line, which equals 5. So in this very simple example, this is a bird count over a period of several days and how many of each type they saw each time they went out to count. Okay, in this next lesson, we're going to talk about estimation. So this is a totally separate journal page from all of the previous ones. You might want to use estimation to gauge those large numbers that you might be looking at, large numbers in the form of distance, in the form of percentage of coverage, things that might be difficult to measure either with tools or biometrics. So for example, if I was looking at a bush, it's a large number of leaves and I'm going to count leaves. I'm not going to do it by counting each and every individual leaf. I may be able to break it down into sections and estimate. Let's say we were looking at this particular flock of birds over here. You cannot count those birds, they're flying. Can you estimate how many are flying? And then here, can you estimate the percentage of sky that is covered in clouds? You want to make as accurate a guess as possible. And remember, there are these tools that you can use. And this is one we mentioned in the last lesson. So here you have, this is approximately what 10 looks like. It's actually exactly what 10 looks like, but this is what 10 looks like. So if you're looking at something that seems like a relatively small number, you could estimate 10 compared to something that looks a lot bigger. This is 5 times as large as that. This is 50. And this is 10 times as large as this one. It's 100. Here is 500. These, again, are estimates. The more you estimate, the more you practice estimating, the better you get. I, for example, live in an area that has a large flock of blackbirds. And that flock over the years has gotten larger and larger. And when I take a walk in the afternoon, oftentimes I'll see that flock together. And I practice estimating how many of those birds are flying, how many of those birds are sitting on power poles or power lines. And I keep practicing that. I never stop practicing. You don't get to a point where you say, okay, I'm really good at estimating. You have to keep practicing that because you're estimating different things with different sizes and different behaviors. So again, here's another tool. And I already gave you that the location of finding this estimation tool. If you're looking out, if you go outside, and remember, we're going to try and estimate lots of different things. If there are clouds in the sky, see if you can estimate what is the percentage of cloud cover. Look at a field. What can you estimate is the percentage of the field that's covered in plant life? Or what's the estimate of the percentage of coverage in a field of bushes versus grasses, something like that. So you want to estimate everything you can look at. So here's what you're going to do with the next journal entry. You go outside, quantify nearby parts of nature, counting exactly anything that you can possibly count exactly, and estimating anything that has to be estimated because the numbers are too large. And you record all of these estimates in your journal. You're also going to write other observations, ABC, and you're also going to sketch and diagram what you are studying. Pay attention to the situations so that you can better estimate what you need to. And for those large estimates, keep those numbers rounded off. So you wouldn't want to say, oh, I see 53 ducks about. Now you probably see about 50 ducks. Okay? So that's the next practice. And number 5, the 5th journal entry in this Hidden Figures unit. You're now going to take all this stuff that you've already practiced. You're going to create one beautiful big journal entry that takes into account counting, estimating, measuring, and timing. You're going to do all of that. You want to be extremely creative and clever. You want to just look at things and go, I can count this. I can measure this. I wonder how fast that's going, and put that all in one journal entry. Then create a graph or a plot or a stem and leaf plot or something that visualizes that. Remember, this is supposed to be fun. If you make mistakes, it doesn't matter because you're going to learn from those. Thanks so much for joining me. We're going to do some more measuring with our next lesson. See you soon.